The DDOGS defense system is a DDoS mitigation, rate limiting, and traffic management system. This system exists as a barrier layer between your website and the world, and this layer can exist in many different configurations. The barrier layer employs a proof-of-work-based strategy, so during periods of heavy traffic, everyone must solve a puzzle. Roughly speaking, the procedure is the following. The client sends a request. The request is intercepted at the barrier layer. If the request is unauthenticated, then the barrier layer selects a puzzle and sends it to the client. The client solves this puzzle and resends the request, which is now authenticated. So this time the barrier layer then lets the request pass through and goes to the website backend for processing. What makes this work so well is the DDOGS system has two novel components. First, the proof-of-work puzzle is completely unique. The mathematics involved are totally foreign to the field of cryptography, so they are mathematically impossible to parallelize. The puzzles have numerous asymmetric advantages. So for example, solving a puzzle is 1,000 times harder than creating a puzzle or checking the solution of a puzzle. The nature of the puzzles allow the inner workings to be kept a trade secret. Even while clients are solving them locally on their machines, they won't understand how the puzzles work. The deployment algorithm is also completely unique. Due to the nature of the puzzles, they can be chained together upon issuance, and this puzzle chain allows for a whole new area of strategy, unlike any other DDoS mitigation competitor. On top of all this, the deployment parameters can be auto-configured for optimal performance relative to any given environment. All of this means that the DDOGS defense system is useful not just for DDoS mitigation, but for rate limiting and all-around traffic management. Let's take a look at a demonstration.
Alright, so in this demonstration we've got a WordPress backend set up as an e-commerce site. We've got a couple of products listed in here. Just walking through the site here, grabbing a few items and putting them into my cart. Show that the site's functional. On the right side you can see the logs from the Docker container that's actually running the application, logging out the request that it's receiving from the activity in the browser here. So we're going to check out now. This entire demo is built on top of running completely locally inside of a sandbox. So our DDOGS instance, our backend web server and its database, and all of the attackers will all be living inside of a Docker environment on this local machine. We've got CAdvisor here for monitoring the various metrics, including CPU utilization, memory, network utilization, and that's where we're going to be keeping an eye on the backend health as we launch a series of volumetric-based layer 7 attacks against it. On the left-hand side of the screen, you can see a terminal that we are calling a Docker Compose file from to launch a simulated attack. The attackers are spinning up right now, grabbing a spot on the network and launching their containers. On the right side, you're starting to see a few of the requests come in from the attack. These attackers are making a simple PHP request that triggers a series of database actions and then return invalid. As a result, they, at very little cost to the attacker, end up causing a great deal of database activity and even greater deal of activity in WordPress itself in the application. And that's what this spike we're seeing here is. So you're seeing us at about 550 megabytes of memory utilization. The significant spike in the CPU utilization in that usage breakdown there. On the right hand side of the screen you can see we're barely able to keep up and print to the screen the PHP output of the requests that are being processed. And on the left side of the screen you can see the attackers very rapidly outputting the responses that they're getting back from the back end. Alright, and we're shutting down the attack completely now. can see the Docker containers of the attackers spinning down. Memory and CPU utilization are starting to drop back off to normal. And we're seeing WordPress make a few self-requests there. Those are not actually coming from attackers. We're closing out and cleaning up now. And in this next bit, we're going to be launching a similar attack, but with the DDOGS system in between. These volumetric attack bots that are coded here have a library in place to solve the cryptographic challenge that we are sending to them. In the wild, obviously not all bots would be willing to perform that proof of work operation, but within the context of this simulation, we're assuming that our attackers are extremely determined and therefore willing to actually output proof of work in order to attempt to attack the site. So now we can see as the attackers are making requests, they're instead of receiving back the 200s from the site, they're receiving back these puzzle objects, which they are then having to solve before being allowed to transit across the DDOGS system to the back end. As you can see, the CPU and memory utilization are significantly lower than in the other case. It's also quite apparent on the right side there with the logs coming out of WordPress that significantly fewer malicious requests are reaching the back end. With that, we're bringing the attack to a close.